How's it going, ladies and gentlemen? Mr. Johnny here again, taking a look at 17.4 stuff, solubility equilibria. So we want to use the KSP expression to determine ion concentration and molar solubility and vice versa. That's our goal. All right, so let's take a look. Saturated solutions. Well, what's with them? All right, so undissolved solid and dissolved ions are both present. So we can get something like this. We got magnesium chloride solid in solution with the ions also being present. Both of them have to be present in order for an equilibrium. So we have a special K for this. We call it the solubility product. So remember that KSP, that's the notation for it. So for the above one, KSP is going to equal the concentration of magnesium ions times the chloride ions squared. Now remember that the solids drop out of our expression, so this won't be there. We won't have this in our expression, and it simplifies to just this. That's it. All right, so note, chloride ion is squared because of the 2, right? The coefficient in front of the chloride and MgCl solid drops out because it's a solid. Cool. So molar solubility in KSP. If you're given the KSP, you should be able to determine the molar solubility of the solute. Example, what is the molar solubility of Ag2CrO4 if its KSP is 1.1 times 10 to minus 12? Well, I know that this is going to be the equilibrium, right? It's going to break up as follows, which means the KSP is going to be this, Ag plus squared times CrO4 minus. So we know that that's equal to 1.1 times 10 to the minus 12 because they gave it to us in the problem. And I know that every time one of these dissolves, I'm going to get 2 Ags. So the concentration of that is going to be 2x. And I'm going to get 1 CrO4 minus 2. So it's just going to be x. So now I'm going to do a little algebra. I get KSP equals 4x cubed. And now I'm going to solve for x. And I get 6.5 times 10 to the minus 5. So that's the molar solubility, right? X is the amount of what's the molar concentration of AgCrO4 because in solution because of the ions we solve for X, and that is the molar solubility. Solubility in pH. As with other equilibrium, equilibrium will be affected by the presence of common ions. If the solubility involves an OH minus, then pH will greatly affect its solubility. For example, magnesium hydroxide. It's typically slightly soluble. It breaks up as follows. If we try to dissolve it in a basic solution where one where the OH minus concentration is already high, it's going to be less soluble. But if we dissolved it in acidic solution where the OH minus is low, then the solubility will be higher. We'll talk more about that in the next section. All right, so solubility in KSP. Solubility is different than molar solubility. All right, so solubility is typically given as grams per liters of solution. So it's using grams instead of moles per liters of solution. All right, KSP deals with molarities. So we need to be able to convert between the two. So if I was given KSP, how do I get to grams per liter? Well, first, I can use the KSP expression to figure out the molar concentration of the ions, right? And then I can use some stoichiometry to tell me the molar solubility of the compound. Once I have the molar solubility, moles per liter, now I just got to convert this moles to grams by using the GFM. All right? So this is my little cheat sheet that you guys can refer to. All right. So what is the solubility in grams per liter solution of Ag2CrO4 solid that has a KSP of 1.1 times 10 to the minus 12? So this is going to be our equilibrium. Our KSP is going to be this. Because, that's how we get it. Ag, there's a 2 there, so we got to square it here. And we only got 1 CrO4, so it's just that. Right. So then, again, I plug and chug, and I'm going to solve for X like I did before. And I get 6.5 times 10 to the minus 5 molar. So that is my molar concentration, or my molar solubility. So now I've gotten this. I used KSP. I've gotten to here. So now I want to use the molar concentration of the ions to get to the molar solubility of the compound, which I just did. It's, I solve for 1x, and that is going to be equivalent to each Ag2CrO4. So I've done that. So last step is to get grams per liter. So I got 6.5 times 10 to the minus 5 moles per liter. And I want to cancel out moles, so I find the GFM, which I did off screen. 331.73 grams per mole is the GFM of Ag2CrO4. And I'm going to have to multiply these together so that the moles cancel out, and I'm left with grams per liter. And my answer would be 0.022 grams per liter of solution. So not very soluble. So to summarize, KSP is an equilibrium constant for a solubility product. It's often referred to simply as the solubility product. Solubility is in grams per liters of solution as opposed to molarity. And pH may have an effect on the solubility of salts. Think common ion effect. All right. So that's all I got. A short topic. Hope you found this helpful. I'll see you in class. Goodbye.